Professor Kumar Appaiah to give a brief introduction. Professor Kumar Appaiah did his BTech at IIT Madras. He did his PhD at UT Austin, and he has been a faculty member in the electrical engineering department for about 10 years.
7 years. 7 years.
7 years. And Professor Kumar Appaiah is an active FOSS user, FOSS promoter, FOSS enthusiast, and you can even say FOSS creator, FOSS activist. In fact, even as a PhD student, he used to maintain Debian, right? Linux, right? Ubuntu, you might know. But if Debian is not there, Ubuntu is not there, right? Debian is used, most of Ubuntu is Debian. They just put a shell and stuff like that. So he was a Debian maintainer. Professor Kumar Appaiah is in electrical engineering. His area of specialization is communication, signal processing, and machine learning. Yeah, we can, I mean, everybody is talking about those things. Kumar Appaiah can also do all of that, but communication is the main thing. One of our staff members, one or two of our staff members created a communication toolbox under his supervision. It is a fantastic thing. And he and I conduct various workshops. We promoted the previous affordable laptop, which we made available for 10,000 rupees. So there are lots of things we have been doing. And he's an amazing person. I'm going to hand over the mic to Professor Kumar Appaiah. Thank you.
Thanks, Professor Kannan. So that was actually very high praise, but I think I will just keep it simple, and I'll actually talk a bit about the philosophy and why one should consider using Scilab, even if you have the budget for these high-end requirements. Okay. So Professor Kannan actually has talked about FOSSI. I'm sure that you would have appreciated it. I just want to talk a little more about the philosophy. When you look at the word free, right? So free is, we often consider free to be something which is low in cost. Okay. But I think that is not the way that you should that's not the only way you should look at it. More importantly, it is the freedom. So to give you an example, let us suppose that there is a particular software that you have, and there is either some behavior of the software, there is some minor issue that you are unable to deal with, there's some bug which causes it to crash, or there is some minor feature enhancement which will make your life a lot easier. In such a situation, you have very few options available in general. What you would do is you would contact the software developer. Like, for example, if it is, say, some product like Windows, then you will contact Microsoft and say, can you please make this fix for me? Now, unfortunately or fortunately, I think we are very tiny. So your niche requirement, it may not be cost efficient for them to support and release a new version of Windows or something of that sort. So, or if it is something very specific, for example, if there is some other tool which you need, you have a small software like some 3D graphic software or something like that, where you need some automation feature. Again, if it is made by a software developer who just gives you the binary, there's no way for you to look into it and make changes. So if you have what is called free software, free doesn't necessarily mean you got it for free. You could have paid someone 5,000 rupees, but you got it. But you got it with the source code and instructions on how to build it. Then what you can do is, if you're really enterprising, you can actually go through the source code and then try to find out what feature is missing or how you can add it. And either you can actually add it on your own, or you can even, for example, if you're saying, oh no, I'm a company, I have to get work done, you can also contract someone to build that feature as well. Okay? So these are many options available with free software, where again, I'm emphasizing that free does not necessarily mean that it's free in cost. You can actually pay, but then not only they give you the binary, you can also get the source code. So you have complete flexibility over what you can do with it. Now, Scilab is a software that falls in the free category. So first, that's something I wanted to emphasize. You are free to look through the source code, make changes, recompile, and make Scilab behave the way you want. Okay. So if you're if you're going to have a startup where you're going to need some numerical computation, Scilab may be a good choice for the simple reason that you don't have dependence on some other company to build the feature that you want. The second thing, of course, is cost. Okay, so fortunately, many of these free software are also available for free, in the sense that you're able to get Scilab for free to download. And this actually matters a lot again if you're going to look into a compare with a corporate kind of environment. So Scilab is follows it satisfies a very niche requirement in that you have basic mathematical uh, and matrix based computation is something which we all require. All scientists and engineers seem to require, especially now. For example, recently I was reading some proof of some cryptographic algorithm, but then people are saying proof is good, but then have you implemented it, right? So we always have to, whenever there's any proposed algorithm or proposed method, you have to implement it. And what better method than to use a generic numerical computing software? So Scilab satisfied that particular aspect very well. The competing products here are largely MATLAB. The commercial offering is MATLAB, which is again very complete and very well optimized software toolkit. The problem is that the MATLAB in term is of course closed source, which means you are unable to make modifications, and more importantly, you are also unable to, I mean, you also have to pay a lot of money for it. So to give you an example, just before I came to IIT Bombay, I was working in a company where the company actually like what happens is that in college, right? So you have MATLAB installed in your college, and some machines you have it, and you learn it very well. Now you go to a company and then you find that you need MATLAB to do some quick operation. Unfortunately, the company has only 10 MATLAB licenses or something, because MATLAB licenses cost lakhs of money. So what happens is that there's a network license and you log in, you try to log in, you find that all the 10 licenses are being used by someone else. Okay. So the company I worked in, every morning, we used to get like 50, 60 emails saying, please release the MATLAB license, because someone used MATLAB and they still have it running while they're just doing something else, not using it. So they would basically have to do this. But in my case, I asked the IT support team in the company to install Scilab on my laptop, so that I was just doing some basic numerical computing. I didn't need any niche features of MATLAB. So I was able to get my work done without being dependent on it. So in that sense, an important point is that the flexibility which Scilab provides is definitely something which you can uh, use to your benefit, especially if you're going to go to a not only a university setting. Of course, in a university setting, of course, your college will say, oh, we don't have budget for the software, something like that. What better option than to use Scilab? But even if you go to a corporate environment where you have a small startup where you're trying something out, of course you will find that 95% of your needs are going to be satisfied by Scilab. Okay, so in that sense, we here strongly recommend that you consider Scilab and other such alternate free and open source alternatives all the time, for of course the cost, but more importantly for the flexibility and freedom. Okay. So now, having said that, let me just give you a taste of what Scilab is all about, and I'll just show you some of the important features. So I'll just share my screen. So if you now open Scilab, right? I've opened it already. I have the latest version. Okay, you can basically see that I have the latest version. Okay, Scilab 6.1. Those of you who have used some other software like MATLAB or Octave will find that it's a very familiar environment. Okay, there's basically a command window, there's a variable browser, and there's some list of commands which you have. And as you all know, Scilab is basically a vector matrix based toolkit. So for example, you can do something like x is 0, step 0.01 to let's say 10, and then it gives you this array, and you can plot x and cos x, and then you get a nice plot and things like that. Okay, then you can do all sorts of matrix operations, like take the transpose, okay, find something like norm, okay, and then you can even find you can do some computations with it, find the maximum of this. So all these things are very, very well built, and all the features that you would desire are largely present here. In addition, you have those who are a little more GUI oriented. You can find that there are these easy to access variable browsers which you will find in other such similar toolkits. Okay, you can just look at these, you can analyze these, and you can even make changes. And things like that. Okay, you can alter these, and you have a history of commands. And in this case, you have a Scilab. Scilab has a small bits and bytes kind of thing where you can get the news feeds. Interestingly, one of the news feeds I got was the very workshop that you're in. Okay, so that's something which you can use to keep up with the latest and greatest. Okay. Now, another important thing is that actually I use, like Professor Kannan mentioned, I use Debian. So I like to show you that you can actually get the full source code for this complete Scilab. Okay, I don't know if this will work. Yeah, so I actually am since I use Debian, I have a single command which will give me the source code. It will actually download the source code and you can actually check. So let me just open it. Yeah, so the full source code for Scilab, all the all of the computing capability, all those things are present here. So I'll give you some examples of what to look for. Okay, so lots of these the C programs where C programs where C source code where all these are written is written over here, and much of Scilab is also written in Java. So you'll also find lots of Java related source code, and you are free, you can just look at the build instructions, okay, and you can actually build Scilab yourself. Okay, so this is installation. Okay, and you can actually look for the help on building Scilab as well, and you can actually just build it yourself, make changes, recompile, and do all those things. Okay, so now next, okay, Scilab, so one major complaint is, oh, this user interface is very strange and I'm not familiar with it, or some such thing can be made. Okay, there are preferences. Okay, you can just look through the preferences and always just reconfigure the behavior way you like, the command line, the keyboard shortcuts and everything like that. You can also use the you can also use the toolbar to basically make your to make your life simpler. You can also use, yeah, you can also use the inbuilt editor. Okay, Scilab comes with an inbuilt editor where you can basically do something like this. X is equal to linspace. Okay, and linspace 0, 10, 1,000 points, and then you can say plot x. Okay, it does some automatic bracket completion and everything like that. Okay, I will save this and then I can just say execute file with no echo, and it just runs. Okay, so it's like you can think of it as an IDE for numerical computing. Okay, using Scilab also results in some, you can also have some other features like debugging and things like that. You can add breakpoints, step through the code. All these advanced features which you would expect from a standard IDE are present here. Okay, so now that you have a basic idea, okay, how should you use Scilab? Okay, so I typically there are multiple ways to do it. Okay, you can either write the code outside and then use this to execute the code. Okay, you can see that there's an exec function which executes the code. You can also use the file, open a file, and then you can actually just choose the file that you want to open and then just execute it. Okay, so and then you can run it. Okay, there are multiple ways to do it. And finally, for those who are a little more command line oriented, okay, you can even do you can even just call this ADV, this is Scilab Advanced CLI. So the command line interface just gives you the equivalent of a command window. So this is basically whatever you have over here is just appearing over here. Okay, so you can actually now do all your things here. Okay, so now you can. So now, what is the advantage of each of these? So typically, you can, the GUI is very helpful because you can write all your programs, debug everything like that. But sometimes you may want to just run something in a headless mode. That is, you want to call Scilab like a script. Okay, so in that case, the Scilab CLI is very useful because you can just run Scilab without opening the GUI. You can do things like this. Okay, so I need to just check the. I think there's a command line option to run it. Okay. Yeah, so I think the minus F. Yes, sorry. Okay, it just runs it. Okay. Sorry, I had a slight error. I have to run this way. Minus F is not CL. So you can run Scilab without having to open, load, and things like that. This is also very useful to just figure out, right? So there are many such options. Okay, and I strongly recommend that you figure these out, because whenever you have to do some automation and things like that, it does not require for you to find some other software. You can just directly use Scilab in a smart way. And you can, for example, if you're let's say you're downloading some data from the website, you're downloading some temperature data or some stock market information. Okay, then you can write a small Scilab code to analyze it. Then you can just add some extra code to automatically download every day, run the Scilab code, generate the plot as a PNG, and just view it. So you can automate lots of things in that manner. So that in that sense, you can figure out all those aspects. Several of the things you will learn. Make sure you actually also check out Atoms. Atoms is a modules database, so it actually enhances your um, Scilab's capability. We can actually add lots of these, modules. For example, if you click on numerical maps, this will maple to Scilab. Or if you look at bioinformatics, you have bioinformatics specific toolboxes and things like that. And finally, the other thing I wanted to mention is that one major, sorry, one major advantage with Scilab is that there is something called XCOS. Okay, this is also something which you can learn through this workshop. XCOS is like a GUI based approach to making these, making systems. Rather than write code, you can actually take these blocks and then drag them, and you can actually put them in the right place and then connect things. So those who are familiar with things like LabVIEW or or GNU Radio or things like that, you can actually just check this out. Okay, you can actually just connect things and then check the parameters and set it. So you can actually make useful programs without writing code by just connecting these boxes. This is actually something which is really powerful and something which is a major selling point of Scilab, because it's a free open source Simulink like tool is available. So this is also something which you can check out. Okay, so while we're talking about Scilab, okay, there's also the other thing I wanted to kind of just mention is that there's also another interesting software called Octave, okay, GNU Octave. I will tell you about GNU Octave also. GNU Octave also is something which is very, very similar to Scilab, except that GNU Octave is again free, open source, but they try to make it more MATLAB compatible. So syntax wise, it's very similar, and code you run for Scilab can be run in Octave with minimal changes. It's also very friendly alternative. But I will tell you one place where Scilab has a slight advantage. Okay, so you know that all of the commands that you're running, for example, if you say plot x, sin x, okay, for example, this is all something like an application programming interface, API. Now, Scilab has been remarkably consistent in maintaining their API across versions. That is, your Scilab programs which are written with Scilab 3 seem to run okay without modifications in Scilab 4, 5, and 6. So in that sense, it's very, very flexible, and you don't have to really worry too much about next version of Scilab changing something. That doesn't happen. However, in the case of Octave, many people end up writing MATLAB-like code, and in the case of MATLAB, right, they have changed many function names. So sometimes across versions of Octave, because of that, some function versions need changing. Okay, they need to be changed, and the same code may or may not work. Recent versions have largely fixed this, and you don't have this issue. But still, Scilab, in my opinion, deviated in the sense that they said we are not going to track any MATLAB API. We are going to set our own API, and their API is actually remarkably stable across versions.
Can I make a comment here?
Yeah, please go ahead.
In fact, we had organized a Scilab workshop, the India team at the time. That was in 2007, I think. In 2007, they all came here, and we conducted this workshop at IIT Bombay, the FC Kohli Auditorium. And there were about 200 people who attended that workshop. Even ISRO people came and so on. And there they asked this question about this compatibility with MATLAB. Their feeling was that MATLAB was actually deputing some people with the assigning some people with the task of intentionally changing the interface, keep changing, so that the open source products that don't have too many people will spend all their time only maintaining compatibility. At that time, Scilab had 23 people. So they asked that a large number of them are required to maintain this consistency. Is it okay if they let go of compatibility with MATLAB? This was the question they asked in 2007. And everybody, a large number of people overwhelmingly said that, yes, it is okay if you let go of this. So we have without that in Scilab, whereas MATLAB Octave is stuck to that. There are, of course, some benefits, but using Octave as a toolbox in Scilab, it gives the same functionality. Sorry for the interruption.
No, no, it was correct. And the completing statement which Kannan made was that, see, because both of these are open source and extensible, one project which our FOSSI team has been working on is a way to combine the best of Octave and Scilab. So you can actually suppose that there is some functionality which is already available in Octave but not in Scilab. You can just call the Octave function directly. From Scilab, Scilab will essentially load the array into Octave, run your function, and then give it back. That is also a very powerful extension, which again goes to show the advantage of using open source software. So in some sense, Octave and if you look at Octave and Scilab, we are not necessarily competitors. Of course, in some sense, they are competing for the same space. But our team has also worked on making them interoperable so that we have the best of both worlds.
If I can interrupt you once more.
Please go ahead.
We could have gone to Octave also instead of Scilab, but then Scilab has Xcos, which is similar to Simulink. Yeah. Octave doesn't have it. That's one of the reasons why we selected Scilab.
Yeah.
To promote.
But you can get the best of both worlds if you use Scilab with the Octave calling functionality, which our FOSSI team has been working on. So that's basically what I want to say. So to summarize what I wanted to tell you, see, these numerical computing facilities are required whether you're doing some control application, some electrical engineering application, or some machine learning application. So in that sense, Scilab offers you again a very, very powerful unit, and you can get good help from of course you can get good help from the internet, good help from our team here. And if you're really enterprising, you can actually start contributing to Scilab. You can make your own modules, like if you like I showed you, if you look at the atoms, right, you can make your own modules like some of our FOSSI team members have been working on. You can add your facilities so that other people can actually just use whatever you are making. You can also add, just one second. For example, of the FOSSI optimization toolbox is something which our team has worked on, and you can see that they've been making releases recently. Okay, you can also just go through the Scilab source code and make changes as appropriate as you deem fit. You can also file good bug reports, solve bugs, and help make the software better. But we all, after this workshop, look to you as ambassadors for not just Scilab but free software, because this is something which is not just students in colleges use, but this is something which is industry capable, as Professor Kannan has mentioned to you. So please do make sure that you learn this well, learn the capabilities, and are able to spread this to others also, so that we can more people, not just in academia but industry, are able to benefit from this. So that's roughly what I wanted to say. But I think now I can take some questions if there are. When using complex modeling programs of small dimensions, how fast is Scilab? How much RAM? Actually, this is a very good question. Typically, the RAM usage is determined by the size of the problem. So whether you use MATLAB or Scilab, you can have, you will roughly require the same amount of RAM. However, in terms of speed, right, recent versions of Scilab have optimizations which make it comparable in performance to what MATLAB can do. So in that sense, the amount of RAM usage will be determined by the size of your problem and not necessarily by the speed of Scilab as such. Okay. Computational cost of complex algorithms. Okay. So almost in all the cases, the computational cost of complex algorithms is determined by the complexity of the algorithm. For example, if you have a polynomial time algorithm, it will run in the similar amount of time in Scilab and MATLAB. If you have some place where you need to do some minor optimization of a loop or something like that, some loop unrolling, something of the sort, there you can do the same optimization in Scilab also. But without knowing what the exact application is, we can't say. It's a good idea for you to try using Scilab and then try using Scilab and ensure that Scilab is not the cause for your slowness of your algorithm before you say, I know I need MATLAB, without MATLAB I can't do it. So that in my experience, 99% of the cases, it was because you can rewrite the algorithm in a more optimal way, and then whether you use Octave or Scilab or MATLAB, the performance has almost no difference. That's something which I have observed.
If anyone has any questions to Professor Appaiah, please go ahead. We'll wait for 1 or 2 minutes.
Yeah. So 8 GB is more than sufficient. Okay. Again, I'll tell you, you can run Scilab on 4 GB RAM, But if you have some really big files to load and things like that, then you need more RAM. So that is this, but that problem is not something which is specific to Scilab. Even MATLAB, if you use, you will have the same requirement. So the overall gist that I want to say is that there may be certain optimizations present in MATLAB but not in Scilab. But in general, I would say 99% of the cases you will not encounter those. If there is a very specific reason why Scilab is not capable, then you may run into issues. But even then, because of the open source nature, there are ways to fix it. And if you fix it for yourself, remember you are fixing it for the whole world also. So that is the good way to look at it. Okay, so then I am available for questions even after during the workshop also. When you're doing other things, our team can just involve me also, and I'm happy to interact with you as and when needed. Okay, so quantum computer, no, I think that's not really possible at the moment, but I don't see why if it cannot in future. So that's maybe the way to look at it. Okay, so I'm done, and yeah, thanks.